Hey everybody, hope you guys are doing well. In this video, we're going to set up Kubernetes cluster on EC2 instances. This is the infrastructure overview. We have AWS account. Within AWS account, we have VPC. Within that VPC, we have 3 EC2 instances. 2 of them would be worker nodes and 1 would be master node. That would make up our Kubernetes cluster. And then we're gonna have a client within the same VPC or same network, which we will use to manage our control plane from a client machine. So 2 worker nodes would share the load and control plane, something that we use to manage our cluster. So before we even start, I do have a infrastructure working. So I have 1 control plane and 2 worker nodes. If I just do kubectl get nodes, you could see both of them. All 3 nodes are in ready state and they've been set up a couple of days ago. I do have a bit of objects created. So if I do kubectl pods, I do have almost 7 pods running on this cluster, and I have access for this cluster from a client machine. And if I do kubectl get nodes on this one, I'll be getting the same results as I saw on my Kubernetes control plane cluster. So 2 worker nodes are sharing the load. If I just do kubectl pods wide, I probably would be able to see that some of the pods are running on one of those nodes. So I have majority of the pods are running on worker node. Actually, they are kind of split in half sort of. So that's good. So now let's start the process. How are we gonna set it up? Before I start, I just want to let you guys know that I'm not inventing anything. I'm just constructing the whole thing from the documentation. It's available. I'll leave the links down below for you guys to check it out. I've also written an article on something like this where I've just kind of, again, consolidated the steps into a simpler manner. All you have to do is just kind of follow the steps and you'll be able to set up a cluster. Before I start, I just want to go over some of the minimum requirements. So when we want to set up a Kubernetes cluster, there are multiple ways. You could have a single node cluster. In this video, we're going to focus on setting up multi-node cluster using kubeadm. And for that, we got to have at least 2 GB RAM, 2 cores of CPU, and 10 to 20 gigabytes of disk just to start with. This sort of requirements are good for dev or testing environment, but if you want to set it up for your prod environment, you may want to look into requirements more closely and what may fit it better for your production environment. The nodes that meet this requirements, the cheapest node on AWS would be T2 medium. So that's the instance type I'm going to use to create 3 EC2 instances. I also want to mention that I've copied most of the commands that I need to a text document on VS Code. So I'll be copying the commands as we progress in this demo. Whenever I type, there's always a typo, so the commands would throw an error. So to avoid that, I've copied most of the commands or all commands to this document, and I'll copying the commands from it. Of course, as we go or type those commands, I will explain what those commands do so that you have a bit of understanding what we are doing here. I'm gonna move this out of the way. It'd be on a different screen, but that's where I'll be copying the commands from. First thing, we just create 3 instances. So as I mentioned, we're gonna have T2 medium, the smallest instance or cheapest instance we can create. It's gonna be Ubuntu, and I'm just naming it K8s. And when it comes to key pair, I have already created key pairs. I'm using one of those, and the security group, I'm going with the default in my VPC, and the disk space is going to be 20 GB. So I'm creating 3 of those. So let's create those. Okay, so 3 nodes have been created. So I'm going to connect to those now. In case you guys are wondering, I have tmux running, so I will be able to work on all the nodes at the same time using its synchronized mode. So the left side, I'm gonna have my control plane, and on the right it would be 2 worker nodes. So I'm gonna connect to the instances that I've just created. So first thing we're gonna do, we're gonna change the names so they are descriptive enough and easier for us to look it up whenever we doing ping, or easier for us to kind of identify. So I'm gonna name this control plane, or maybe I'll just name it master. Okay, so all the nodes been named appropriately. So now we're gonna start the process of preparing our nodes. So when it comes to setting up nodes for Kubernetes clusters, so we'll prepare our nodes so that Kubernetes cluster can be set it up and the tools can be installed. So there are some of the requirements. We gotta nodes gotta have some of the tools in place or settings in place so that the tools can be installed. So we'll do that first, and then we will install the required Kubernetes tools, and at last we will initialize our cluster so that we can create our Kubernetes object, the parts of the containers we need to. So to run all those commands, it's better to run it as a sudo. So I'm going to switch it to a root for all of my nodes. So all the commands need to be run on all the nodes. So let's just do that. I'm enabling synchronize mode on my tmux so that whenever I type a command on any pin, they get typed on other pins as well. So let's switch to sudo. Clear a window. So the first thing we're gonna do, we gotta make sure that our nodes have unique MAC addresses and UUID. So that's something's gonna be very likely that they would be unique, but in certain cases it's possible that you may not have it. So it's a good idea to check it. So checking here. All of them are different, so we don't have to worry about that. So the next thing we're gonna do, we're gonna disable the swap. So swap has to be turned off for kubelet to work. Kubelet is one of the tools that communicates with cluster all the time, providing the status of the worker nodes and what the worker nodes are doing. So we gotta have the swap turned off for that tool to work, and then we gotta make sure that we enable the IP packet forwarding between the different interfaces. So when we create our pods, they could be sitting on a different node. So and they may need a connection between different interfaces. So we gotta make sure that we enable the IP packet forwarding between two different interfaces. So to do that, I was just running the echo IPv dot forward, setting the value to 1, and then we're saving that to systemctl K8 config file. That's where Kubernetes would be looking for its configuration. And then after enabling it, we'll just restart the systemctl setting. And now the setting should have been saved. So now we gotta make sure that the changes have taken place. So if we get the output to the value set to 1, that means that it's been configured properly. So now we gotta install the container D. So container D is a container runtime. It's kind of pretty much standard nowadays. So that's what we're gonna do. Docker also supports container D, so we'll install container D. Before we do that, I'm gonna update my system. So this will take about a minute. So all of my nodes been updated, so we'll just clear the window here. So, and now we can install containerd using apt-get. So I'll just do apt-get install containerd. To confirm it's been installed, we can run ctr-version and it'll tell us that the container has been installed and what version has been installed. So you should see something like this where it's displaying you the version of the containerd. So containerd is being installed. So the next thing we're gonna do, we're gonna install the CNI plugin. So CNI plugins are required for any sort of a network plugin that we wanna install down the road. So we gotta install the CNI plugin. So we do that. It's gonna be manual process. So we will create the folder for its binary to live, and then we will download the binary from the official website. So I'll leave the link where you'll be able to download this binary. So in case the latest version changes, so you'll be able to pull it the latest version from the website. So I'm installing 1.6.1, that's the latest one at the moment. So I've just downloaded it, and now I'm gonna just essentially untar the binary into the location or the folder that we created before. So now clear that, and now what we're gonna do, we're gonna configure our containerd so that it's set up in a way that that the kubectl or kubelet commands expect. So we will create the directory. It's possible that this directory may get created when you install the containerd, but if it doesn't, you may want to create the directory, and then run containerd config default. So what we're doing here, we're grabbing the default configuration of the containerd that we just installed and saving its configuration into etc containerd config.toml file. So once the file has been saved, we will make some of the changes so that it is working the way we need to. So the first thing we're gonna check, we're gonna make sure that the CRI plugins aren't disabled. So if I just do head on the configuration file, if I see anything of CRI or CNI plugins are listed under disabled plugin, we're going to remove that. In our case, our disabled plugins are none, so I don't have to worry about it. The next thing we're going to do, we're going to enable the C group driver for our containerd runtime. So it should be listed under containerd runtime runc options. Okay, it's nothing showing up. Maybe I'm typing something wrong. Okay, so yeah, this is the section where we need to make sure that containerd able to use system C groups. System C groups are required for our resources isolation. So if we want to run containers, we gotta make sure this is enabled. So set the value to true and save the file. And after doing that, we may have to restart the containerd service. So now we have prepared our nodes, and now we can install the kubelet or kubeadm tools that will help us set up the cluster. So first thing we're gonna do, we have to add the GPG key, public signing key, and add the Kubernetes repository so that we can install those tools. So what I'm doing here is just downloading the GPG signing key so that I can verify the authentication, or I can essentially kind of verify the source is legit. So after doing that, I'm gonna add the Kubernetes repository into my repo list, and then just do apt get update, and then we'll install the tools like kubelet and kubeadm. So kubelet, I mentioned before, it gotta have it on each node, and kubeadm is something required for us to initialize our cluster. So both tools are required, and after doing that, we will install kubectl. But the kubectl doesn't need to be installed on all nodes. It needs to be only running on master, where we'll be managing our cluster. Kubectl is the tool that we use to manage our cluster. So I'll install that just on my cluster. Just on my control plane. So once my kubectl tool is installed on my control plane node, what we're going to do now, we're going to initialize the cluster. So to do that, we will run kubeadm init. And when we run initialization command, it's a good idea to specify the pod network. If you don't, you don't have to worry about it, but I think that then a kubeadm tool may assign the network that you may not want to assign to your pod network. So it's a good idea to specify the network. So when you run kubeadm init command, it goes through the initialization process. It downloads all the certification keys that it needs to and put it in the place that it should be, so that whenever you run Kubernetes tools, it can look for that information. And at the end of the output of the kubeadm init command, you're gonna see the kubeadm join command, and that's the command you're gonna run it on worker nodes so that they could be a part of the cluster. So I've just run it on worker 1 and I'm running it on worker 2. Oh, sorry. I'm just still on the worker 1, running it on worker 2, and now this should be part of the cluster. You also see the output above the kubeadm join command, that how you can configure your cluster to be run as a regular user. So this is something that we need to run it on our control plane machine, so that once I exit out of my root, any sort of a user should be able to run kubectl command. So I'll configure our kubectl for master or control plane node. Now just copy the file, the configuration file. You also gotta change the ownership of the file so that any regular user be able to run the kubectl commands to get nodes or get parts. After doing that, we gotta install the network CNI plugin. So there are a bunch of CNI plugins available, and I'm going with the Calico one. It's relatively popular. There are instructions available on the website, so I've just got those steps and put it in my text file that I showed you before, and I'm just running those. So while this is initializing and installing all the required parts that it needs to, there are a whole bunch of network plugins available for you to pick from. So I'll leave the link below that if you want to install any other network plugin, you can go with that. The reason that I've used Calico is just I'm something familiar with Calico. A lot of people also use Flannel. So if you go to its Flannel's page, it'll provide you the instructions on how you can install Flannel plugin on your cluster. So if you don't install a network plugin, your nodes may not communicate or parts may not communicate. So if I would have just didn't install this network plugin, my nodes would never have joined the cluster, but they would have never been in the ready state. So we gotta have a network plugin installed for nodes to be in a ready state. So now next thing we're gonna do, now I'm gonna exit out of root, and if I just run kubectl get nodes, okay, so it looks like it's not. I configure it for root while I ran out those commands. Okay, I exit out of it, I didn't need to. I'm gonna reconnect to it. So now I'm gonna configure this user so that I could run kubectl commands without running it as a sudo or root. So again, we're doing the same thing what we did before for root. So we're creating a kube directory within the home directory of Ubuntu user, and then copying the files from /kubernetesadmin.conf and moving it to the newly created folder and changing the ownership. Now if I run kubectl get nodes, I should be able to get the list of my nodes. So now we're gonna configure some sort of a client where we could get the list of our nodes. So currently this client is configured to get the information about the cluster that I created before starting this video. So what I'm going to do, you could copy the configuration of our SSP, but if your client doesn't have the authentication key added to its added key SSH keys, you could move it manually. So that's what I'm going to do here. What I've done, I've created a configuration file, and then I'm gonna replace it with the existing configuration file. So I'll just move this newly created configuration to the location where my existing configuration is. So I'll replace that. Of course, I have to change the ownership, so I'll do that real quick. And if I run kubectl get nodes, okay, okay, something's wrong with the file that I copied over. So I'm pretty sure, I think I probably would have included the text that maybe I shouldn't have. So let's see. Oh yeah, just seeing this command copied along. So just save this one now, and if I run kubectl get nodes now I could list my nodes. I could even create pods just from my client machine. If I run kubectl run, I'm gonna run nginx pod, image would be nginx. Okay, so now my pod has been created. So if I just run kubectl get pods, it should list the pod, and it's in a running state. So yeah, so this is it. That's all I would like to show you guys. I will leave the link for each documentation I mentioned throughout the video, and even the article that I was referring to. I will also leave the link for the file that I've used to copy the commands from, so that you can reference to. Do check out the article. It's essentially the same thing that what we did in the video, but essentially in an article form. This is it with this video. I hope you find it informative. If you did, please do consider liking it. Yeah, that's it. Thank you.